If you want to learn how to write complex queries, this is the video for you. In this video, we'll write a query to solve an SQL problem. We start with the description of the problem, see the sample data, and slowly write the query until we get to the correct result. You can use this process to write your own complex SQL queries. For this video, we'll use an SQL problem on the HackerRank website, which is a website that has all kinds of coding challenges. I've put the link to this specific challenge in the description below if you want to follow along. This challenge is called placements. We have three tables in this problem: students, friends, and packages. The students table stores information about, well, students. The friends table stores records about a student and their single best friend who is also a student. Packages stores a list of salary packages offered to students. In this example, we need to write the names of students whose best friend got offered a higher salary than them. Here is an ERD of the tables. The tables are small and all of the ID values in the same tables represent the same thing. The friend ID in the friends table is also an ID that can be found in the students and packages table. On the challenge page, we have some sample data here. So the first thing we'll do is create some tables and add this data. This SQL can be run to create the tables and add this sample data. I'll add a link to this script in the description below. Once we run these queries, we'll have data in the students, packages, and friends table. Let's get started with the problem. What query do we need to write? We need to write a query to show the names of students whose best friend got offered a higher salary than them. This sounds complicated. How do we work this out? The first thing I like to do is write a simple select. We'll start by selecting the columns in the students table to see our student data. We can see our four records here, with the ID and name columns. What's next? The problem says we need to find information about best friends, so let's try to show that. We'll write a query to find the ID of the student's best friend. This is stored in the friends table. We can add that to our query by adding an inner join and joining on the ID in both the student table and the friends table. We'll add table aliases to both the students and friends table to make them easier to work with. We'll also add the table alias to each column in the select clause as well. Now that we have the friends table in our query, we can show columns in the table. We'll add the friend ID to our select clause so we can see the ID of the best friend. I think it may be helpful to add a column alias to some of our columns to make it clear what they represent. This is especially helpful when we have an ID in different tables here because it can be confusing as to what it represents. So we'll add an alias to the ID and name columns. We can run the query and see the three columns here. We can see the friend ID, which is the best friend of each student. What's next? We need to do some kind of checks for salaries, so let's show the salary offer for each student. We can find the salary information in the packages table. Let's add that table to our query using an inner join. How do we join it? The ID in the packages table matches to the student ID, so we can join on that column. Once we've added the table, we can add the salary into the select clause. I'll add it after the student name, so it's clear that it's for the student and not the best friend. I'll also add an alias to give it a better name. We can run this query and see the results. We've got the salary shown for each student now. The problem says we need to write a query to show the names of students whose best friend got offered a higher salary than them. We've got student information, the student salary, but we don't have the best friend salary. Let's add that to our query now. As we know, the packages table has salary data. And we know that the columns in the friends table, both the ID and the friend ID, match to a student ID and also the package ID. But the salary from the packages table is already being shown in the query, and it is the student salary, not the best friend salary. What can we do? There's no other salary column to add. Let's look at this join clause. We've joined to the packages table based on the package ID matching the student ID. This means the packages represent the student salary data. We want the best friend salary data. Can we join the package ID to the friend ID instead? We could update this, but we'll lose the student salary. However, we can join to the packages table again. We can add another inner join query and join to the same packages table. This is possible and commonly done in SQL. We add a join clause here that says join from the friend ID to the package ID. The one thing to keep in mind is that the table alias needs to be different. We already have a table with an alias of p. We could call it p2 if we want. However, I prefer to use aliases that make a bit more sense, especially as queries grow larger. It can be hard to remember that p2 refers to the best friend's salary. So let's rename our aliases to use ps for the package for student, because ps stands for student. We can use pf for the package table for the best friends. We'll need to update it in the select clause as well. This makes it easier to know that ps is for students and pf is for friends. Now let's run this query. We don't see any changes in the data, but we don't get any errors. Next, we'll add the friend salary to the select clause so we can see it. We'll give it an alias so we know what it means. We can run the query again. We can see that we have the friend salary in the results. We can see it's different to the student salary because it refers to a different person. This is good. If it was the same value, then we'd have an issue in our query. If you have the same value here, it's probably because you're selecting the PS salary value in both cases, which is the student salary, or the join is the same for both tables. Let's move on to the next step. We need to find rows where the best friend's salary is higher than the student salary. This is much easier to do now compared to the start of this video. We can see the student salary and the friend's salary. We need to see the rows where one is higher than the other. We can do that easily with the where clause. So we'll add a where clause to our query and say where the PF salary, which is the friend salary, is greater than the PS salary, which is the student salary. We can run the query and see our result here. We now have 3 rows and we can see that in all of them, the friend salary is higher than the student salary. This is good. What else do we need to do for our problem? The problem description on the page mentions some other things. It says names must be ordered by the salary amount offered to the best friends. It is guaranteed that no 2 students got the same salary offer. The guarantee means that we don't need to do any secondary ordering. But we need to order our results based on the salary offered to the best friends. It doesn't say whether it should be ascending or descending, so we'll go with ascending as a default. In our query, we can add an order by to the end of the query. We order by the pf.salary because that's the friend salary and the column we need to order by. We can run the query and see that the data is ordered. It may look just the same, but the order by ensures that the data is in the order we specify. What's next? Our problem says we only need to see the names and not all of the other columns. I added these columns to help us write the query and identify that we're seeing the right data. But now we can remove these columns from the select clause, leaving only the name. We don't even need to use a column alias if we don't want to. We can run this query and see 3 rows, with the names as we saw earlier, Samantha, Julia, and Scarlett. Let's check the expected output on the problem page. We can see the output here matches what we got from our query, so that shows us that our query is correct. We can see in the explanation section the same kind of information we saw in the earlier steps in our query, as well as the reason why each of these student names are shown. So it looks like our query is correct and we've solved this problem. Here is our query again. We select just the student name from the students table. We join to the friends table to get data about their friends. We then join to the packages table twice, once for the student salary information and once for the friend salary information. The table aliases and join clauses are different for each of them. We add a where clause to filter the data where the friend salary is higher than the student salary. And finally, we order the results. I hope this video has been useful to you in helping you understand how to write a complex query. If you want to see another example of writing a complex query, check out my other video here, which follows the same approach but uses a different problem. If you want to learn more about database design and SQL, visit my website at databasestar.com. If you like this video, consider subscribing to my channel. Thanks for watching.